regions of space with so much gravitational pull that they trap light and warp time. Just a small black hole in our solar system would throw planets out of orbit and tear our sun to pieces. If that wasn't scary enough on its own, black holes can hurtle across the galaxy at several million miles per second, leaving trails of destruction in their wake.
Here's what blows my mind about that. 7 million miles per second, right? Or whatever. Or like... If like, how are these black holes not just like flying around killing everything? You know what I mean? Exactly,
22.
We wouldn't even see it coming. Like our like
gamma rays. The most powerful type of explosion in the universe, gamma ray bursts are intense, high-frequency bursts of electromagnetic radiation that carry as much energy in milliseconds as our sun will give off in its entire lifespan. If one of these rays were to hit Earth, it could strip the atmosphere of ozone in seconds, and some scientists even attribute a mass extinction 440 million years ago to gamma ray bursts hitting Earth. 21. Zero gravity. Scientifically referred to as microgravity, this condition occurs when an object is in a state of freefall and appears weightless. Although it may look like fun to float around like astronauts, prolonged time in zero gravity conditions can have long-term mental and physical effects on humans. 20. Cold welding. Here on Earth, gases in the atmosphere react with metals to create a thin layer of oxidization. The vacuum of space, however, has no atmosphere, and therefore causes no oxidation to form on metals, leading to an interesting reaction. This reaction is called cold welding, and it occurs when two metals of the same molecular makeup are pressed together and fused together permanently as if they were one piece. While this may sound neat, it caused quite a few problems on the first satellites and can make in-space repairs very tricky. 19. Alien life. The universe is massive.
They're already among us.
Unbelievably old, so the chances of other planets similar to Earth evolving life is not unlikely at all. According to Fermi's paradox, the high probability of extraterrestrial life out in space is contradictory to the lack of apparent evidence supporting it. At this point, we aren't sure which is scarier, the fact that we might not be alone in the universe, or the possibility that we are. 18. Rogue planets. Launched into space after the formation of their planetary system, rogue planets are planetary bodies that are free to roam the cosmos, crashing into things as they go. Because they do not orbit a sun, rogue planets often have freezing surface temperatures.
Right.
However, due to their molten cores and icy insulation, some scientists theorize that these free-roaming planets could contain massive subterranean oceans that support life. 17.
What?
Travel times. In 1969, it took the Apollo 11 lunar module 3 days to land on our own natural satellite, the Moon. Since then, our technology has increased rapidly. We could expect to reach Mars in 7 to 9 months, and reaching Pluto would only take about 10 years. Distances outside of our solar system become even more extreme. Even traveling at the speed of light, it would take us over 4 years to reach the nearest star, Alpha Centauri, and over 100,000 years to reach the...
Listen, I don't give I don't care that I'm losing viewers. I'm watching some space stuff while I'm eating.
...galactic center of the Milky Way. 16. Extreme temperatures. Depending on where you are in space, chances are you're going to find yourself in some pretty extreme conditions. The heat put off by a supernova can reach temperatures of 50 million degrees Celsius or more, 5 times that of a nuclear explosion. On the opposite end of the spectrum, the cosmic background temperature of space measures minus 270 degrees Celsius, just slightly warmer than absolute zero. You definitely won't want to forget your jacket. 15.
Already full.
The darkness. Being scared of the dark isn't just a silly thing that children experience. It's an evolutionary trait humans develop to protect themselves from dangers lurking in the unknown. The only reason adults nowadays don't fear what they can't see is because they have learned through experience that the likelihood of monsters hiding under the bed is very low. In space, however, darkness represents a completely unexplored emptiness that continues for an infinity. So being afraid of the dangers that lurk beyond our sights is a completely understandable reaction. 14. Magnetars. Magnetars are incredibly dense neutron stars. In fact, they're basically an entire star crushed into a sphere only 15 miles across. 1 teaspoon worth of a magnetar contains the same mass as 900 Great Pyramids of Giza. They are also the hosts of the strongest magnetic fields in the known universe, fields so strong that anything that gets too close is ripped apart at the atomic level. 13. Musculoskeletal atrophy. Maintaining a healthy level of exercise is hard enough here on Earth, but in the zero-gravity conditions of space, it can be even harder. Astronauts visiting the International Space Station have exhibited signs of significant muscle atrophy after only 6 weeks in space, and that's with a rigorous health and fitness program. 12.
Yikes, dude.
Venus. Despite getting its name from the Roman goddess of love, Venus is perhaps the most hellish planet in our solar system. With surface temperatures of nearly 500 degrees Celsius, atmospheric pressure 90 times that of Earth, and constant sulfuric acid rain, simply landing on Venus would kill you in moments. This definitely isn't a planet you'd want to have a picnic on. 11. Dark matter / dark energy. We know very little about our universe. In fact, we've only seen less than 5% of the stuff that it's made of. The other 95% is dark matter and dark energy. About 1/4 of the universe is made up of dark matter, mass that we can't see or find in space, but must be there due to its effects on the behavior of its surroundings. The rest of the universe is dark energy, the true nature of which is mostly unknown. However, we're pretty sure that it plays a crucial role in the expansion of the universe. 10. Background radiation. The Earth's atmosphere and magnetic field protects us from some really nasty stuff, namely radiation. Cosmic rays, solar winds, and electromagnetic particles permeate the universe, so much so that astronauts traveling between Earth and Mars would receive a full-body CT scan's worth of radiation every 5 to 6 days. Any that didn't succumb to radiation sickness before reaching their target would almost certainly develop severe cancer in their lifetime. 9. The expanding sun. Our sun is constantly using nuclear fusion to combine hydrogen and helium together in order to keep itself burning. However, its hydrogen is not infinite, and as it gets used up, the sun will get hotter and hotter. Eventually, it'll get so hot that the Earth's atmosphere will be burned away, and our oceans will boil and evaporate completely. Then, once all the sun's hydrogen is gone, it will expand outward into a red giant, consuming the Earth once and for all. 8.
Poetic.
Hypernovae. With 100 times more energy than a standard supernova, hypernovae are powerful explosions that occur upon the death of a massive star.
In 5 billion years. It blows my mind that we can predict that the sun will blow up in 5 billion years, dude. We are so tiny. We're a grain of sand, dude. The Earth is a grain of sand in the universe. We are a molecule in that grain of sand.